What's up, everyone? Let me just confirm that everything is working the way that it's supposed to be. It seems like it. Yeah, there's
What's up, everyone?
All right. Perfect. All right. So I just wanted to go over a couple things. I was just watching surfing through YouTube, and I came across a person out there who was vibe coding and had a Mac Studio M4 with 64 gigs in it, running oLlama and running on Quinn 3 30B coder. And so I was trying to explain to him that oLlama doesn't have an MLX back into it. It's running Llama CPP, and that he'd be better off running oLlama to get, or not oLlama, oMLX to get the full benefit of the MLX framework on the back end, being that it's designed specifically for Mac OS, and that he needed to upgrade his models to the Quinn 3.6 series of models. And so he started downloading it. His internet was really slow. And so for all of us Mac developers out there who, or maybe not developers, but people who are trying to get into the AI coding and vibe coding, as we call it apparently these days, frameworks matter, right? And so on a Mac, we're kind of like, I won't say second class citizens. Well, technically we are. Everybody that's not running CUDA from NVIDIA is technically a second class citizen, but that's a completely different story. And so anyway, I was trying to explain to him that he needs to go get oLlama and an MLX model, a Quinn 3.6 series model, and upgrade from that 3 version that he was running. And Quinn 3 30B coder is a MOE, mixture of expert model, so it only keeps however many billion parameters active at any one time, which does make it faster, granted, but that he would get a significant benefit by running the Quinn 3.6 35B A3B, which is another newer MOE model, or if he really wanted the best effort, the best quality, better way to say it, that he should go ahead and run the Quinn 3.6 27B, a dense model, slower because everything stays in memory, but the output is a little bit better. And so I've already installed Quinn. You can get the DMG from right here or get it straight from their GitHub. And I believe they have releases right there, so you can grab it right there too, either way, which technically all the DMG, if you look at the bottom left, points to the GitHub release, so it's the same thing, technically speaking. But that's the repo for it. That's the web page for it. And essentially, once you get it installed, you'll get this icon up here in your little finder bar, and you can click on it and go to your dashboard, and it brings up their little front end. It supports OpenAI API calls. It supports the Anthropic method of doing things. You can launch any of their editors directly just by, you want to run open code, you can click that, grab your terminal, which I have on another screen over here, and paste it in, if you could see that. And it'll launch open code hooked to oMLX with whatever models you've got downloaded. and you can select the model, it'll load it, and you go to town. Of course, you want to start that from your project directory, which I keep all mine in developer, Git repos, and then all of the different repositories I've got going on in here. Get into whatever repo you want and then launch it. But more about oMLX here. So they run all MLX backend. And when you're running on an Apple, this is what you want. They have a model downloader. You can come to your models and go to the downloader and do a search for a specific model. Prefer MLX only, because again, you want your model trained on MLX because you're running on MLX, because you're running on an Apple. And so you've got the MLX backend, you've got a model that's tuned to run on MLX, which all equals more speed. And so it would basically be, you can see I was searching right here, so we can just search for Qwen 3.6 27B. MTP is multi-token prediction on a 4-bit quant. And it'll pull them all up. And you've got the MLX community. You've got just randos out there that have trained their own for whatever reason. Me personally, I normally won't run just some random model. Not that I don't think it's unsafe. It's just, I don't know them and don't trust them. But I know MLX community's good. Unsloth, they're good. You know, some of the bigger players out there who are consistently putting out quality models are the ones I'll run. And yeah, and then so basically you download it, and then if we go to the manager, these are the ones that I have running, which I've deleted a lot of mine off of here because I've recently picked up a RTX Pro 4500 Blackwell and have it in a Linux box sitting here under my desk. My machine, this laptop, by the way, is an M4 Max with the 40 GPU cores, 64 gigs of unified memory, running the current OS, and 2 terabytes worth of SSD in it, and it works fine. Not the fastest in the world, and I do hit memory constraints depending upon what I'm doing. So like, let's just say I want to fire this uncensored model up. So I should be able to come over here and like, let's go into this guy, which is what I've just about finished. And I launch my Pi agent, which is what I run. I do have OpenCode installed, but I prefer Pi. And let me go ahead and do that update. Get that done. And so right now I'm hooked. I just downloaded, actually yesterday, the Thinking Cap Qwen 3.6 with built-in MTP to it. It's actually, let's fire it up. Why not? We'll come back over to here. We'll go over to a new desktop, and then we'll go. I run LM Studio. Seems to be the fastest so far. I tried using VLLM on my Linux box here, but I got to get it tuned a little bit better to fully commit to it. And so for LM Studio, they do run, no, not the models, it's the developer page right here. No, it's the chat. Oh, it's under settings. They have Llama CPP, but it's the CUDA version, so it's like super fast because this is a CUDA card, the RTX Pro 4000. So I mean, I get access to right. So you can see I got 32 gigs of GDDR7 ECC memory. Not a super lot, but I mean, everything's so damn expensive these days that it's just not even realistic. You know, a 200 watt power cap on it, which is good because again, this is, you know, it's only a 5700 X3D. I got 64 gigs of RAM, so it's AM4, DDR4, PCIe 4. The card is PCIe 5, so I lose a little bit of bandwidth on that, but not that big of a deal because I don't do any inter card transfers or whatever, so it's not too much of a concern. But these are the models that I have. They're all some variation of the Quinn 3.6, whether it's the 27 billion parameter dense model or the 35B A3B, which is a mixture of experts model. All of them are running at 4-bit quant because, again, I like to have a bigger context because some of the projects I run or work on are kind of large and the extra context is good. So I run it, the 35 billion, I can run it max. The 27B, I run it about 160K context on it. And so we'll just do like watch NV SMI. So we'll just keep that running. And then we'll come back over here to my terminal and then we'll go models. Oh wait, I'm already on the one I want. So that's the 27B. Let's let it get warmed up. And so we can jump back over here and we'll watch the memory start to climb. Or it should anyway. Yeah, there it goes. All right, and so see, I'm pushing 30 gigs out of the 32. And again, for this one, it's 166,000 max context. And I've been averaging about 57 tokens, or yeah, 58 tokens a second on average. Let's just see, let it dig through real quick. So you can get an idea of how quick it is. And again, this is the 27 billion parameter is a dense model. So all of the 27 billion parameters are in memory right now, which makes it a little bit slower, but you do get better quality output. And not just my opinion. If you look at any of the AI leaderboards, it'll tell you the same thing. But if you're light on memory and you're looking for speed, that 35 billion MOE is the way to go. And so you can see, and this repo is, I don't even know how big it is actually. Let me, so 2.5 gigs. So not too totally giant, but, and you can see, so that was, you know, averaging about 63.7 tokens a second, which is pretty good, all things considered. And again, this is running off of my PC. This isn't oMLX working. But let's change models real quick. So let's switch over to the 35B here. Let me get that warmed up. And so it just dumped everything out, and then it's going to load the new model in. So we give it a second. There it goes. And it should push it right up to 30 gigs as well. Close to it, 28. And on this one, I've got the 256,000 context window. And then we'll run that same command. So you can see, you know, we're pumping 100, 150 capped out at 162 average, which again, it didn't do a full deep dive in it, but it was just looking at some of the things that have changed because I added some stuff here this evening. And you can see it's quicker, right? It's a lot faster, but again, the output you get from it when you actually have it working for you is not quite as strong, we'll say. And again, any local model you run is these days, they're definitely, exponentially better than they used to be, but they're still not frontier level by any stretch of the imagination. I mean, they're not going to beat Grok. They're not going to beat any of the GPTs. They're not going to beat damn any Anthropic model or anything like that. But for people who don't want those subscriptions, or you've got data that you don't want to get out there to the world, Win 3.6 for coding is definitely the way to go. And so, they're pretty good. They work pretty good. I was actually wanting to try the thinking cap for the 35B too, but all things considered, I didn't think it was really worth it because again, the 35B in my particular setup is fast enough. I mean, 80 tokens a second, which that's on the low end too. Again, I tested it the other day and I was averaging about 175. 175. Even Grok was like, "What? I don't think so." And then he ran a test and was like, "Damn, okay, you were right." So, it works out pretty good. And then, so if we get back over right here, let's do this first. We'll just quit out of here, and then we'll come back over my remote desktop, and then we'll come. Wait, what did I do with my LL or via LM Studio here? Let's go ahead and just close that out. I don't really need it, and then that should have closed out the model as soon as it gets done exiting. Oh, I guess I gotta actually shut it down. There. Okay, so that's unloaded. We'll stay off of this. Isn't necessarily pertaining to the Macs, so come back over to here, and then now we'll put that in the background. We'll jump on to one of these guys, and so I'm going to go ahead, go back to the dashboard. I'm going to go ahead and use open code for this because my Pi is not set up. And so we'll just drop that in there and we'll pick our model and we'll do the 35B. We're going to do the 6-bit. So it's a little bit smarter, more data. The 4-bit quants are, again, there's like generally 16 bits in there and they cut some of them out without losing a whole lot. So you can see I've got a bunch of them in here. Some of the older, well, those are for different things. The uncensored, the D-Flash is the MTP. So he predicts tokens and recommends it to the main model. And if it chooses to take them, it runs it faster, basically. And so we'll grab this guy right here, 6-bit. So it's setting up its config, and then you can watch it. Like when I start doing stuff, it caches stuff local on the disk, and I've got 7.8 gigs out of 55 gigs that I've allocated to it in 79 files. So we'll just clear all that cache out just so that we can watch it build. And then I'm already in my Pimp Audio Studio directory. We're going to say, do a deep review of this code base and tell me if you see any memory handling related issues, and then let it get in there and churn through. And it's loading it up right now. You can see my RAM usage is climbing. Excuse me. We'll give it just a second. There it goes. And then we can actually watch it as it starts doing things. And so now that model is just loaded up. There's the request right there. And again, it's you can adjust it, but I leave it at the defaults pretty much. So we've got a 44 gig usage soft limit and a 49.2 gig hard limit. And once it hits close to the hard limit, it doesn't crash, but it basically throws a message up saying that you've reached your maximum usages or whatever. And so it doesn't proceed. And that's the problem with running the bigger models, is you got to have the memory to do that. And it's not so much will the model fit, it's do I have enough room for the context to go along with it? Because, the KV cache takes up a lot of memory too. And when you go in there and don't adjust anything and you're running $250,000 context budget and you've only got, 32 gigs of memory and you're trying to run a 70B model, which wouldn't even fit to begin with, but you're trying to run a dense 27 billion model, which is going to take up pretty much all of that with the giant context. Now you've overdone it. And so your harness has to be able to auto compress that, just like you see ChatGPT or Grok or Opus or, whomever. They'll automatically compress the context once you start bumping the limits of the context, so that it keeps some free memory, and so that it doesn't OOM on you. And so he's digging, but you can see it's a lot slower right off of the drop, which I am running a 6-bit model versus a 4-bit model, and that does make a difference. But it's just overall slower on the Apple because it doesn't have the CUDA cores and the GDDR7 memory and all that high bandwidth that those cards bring to the table. And that's why they dominate the market, because they've been around the longest and their software stack is like been around forever. And so everything's built around it. Whereas, the MLX framework is catching up. Maybe like on the M7s and 8s and 9s and 10s, as the future goes on, they'll come up with a way to make it significantly faster. But as it stands today, there's no Apple that's going to beat an NVIDIA. And that's just the fact of the matter. Now, they do beat it in the sense that before our memory crisis started going on, you could go out and spend $10,000 and get you a M3 Ultra Studio with 512 gigs in it of unified memory, which would allow you to run, giant models, run 400 billion parameter on that thing. Super smart. It ain't going to be the fastest in the world, but it fits, and you can run it max context, and you can run it all day long, set it loose on something and just be good, But you see how long this has taken, where that 4500, it would already have given me some answers by now. But on the Apple, I'm running 100% on my GPUs. And again, I got 40 cores, 64 gigs of memory. And I've got a couple of other things open, so the memory is not 100%, just the model running. So the Brave browser burns up a lot, and I think I got Xcode running back there, and a couple of other things. The OBS I'm recording on the Mac itself, and so that's burning into the memory too. But it all kind of counts towards the budget, and so that's kind of what you got to take into account. And again, it's solid. It'll run as long as you don't run out of memory. It'll run forever. Again, I've done a lot of good coding with local models, absolutely. But again, they are never going to reach, I won't say never, but not today. They're never going to reach the frontier level. They can get the grunt work done, and then you come back through with your frontier model and have it tune everything up. So you basically have the grunts doing all the grunt work, and then you have the officers coming in, kind of cleaning up after the fact. That's how I like to look at it. And so we'll let that run for a minute because it'll take it a minute. And then so like this program right here is my audio studio that I've been working on for a minute. And actually I got another video up about some of the LoRa training stuff I've been working on, but I've been tuning. And so I've made some changes. I got it where we can resize windows, we can collapse windows, added a full help section where you can basically search and stuff and pull any kind of details about, whatever the case might be that you're looking for. I got my data set builder where if you've got the memory, I've tuned it up where we get better caption data from your data set and better lyrics. Not so much better lyrics, but just we still get the lyrics either way. So we've got the lightweight side, which is using demux and a couple of other things. And then I ended up adding in the native ACE captioner and ACE step transcriber, and ended up basically quantizing them down to 4 bits and pulling out the text to audio piece of it and strictly going with just the audio to text side of it. And you can actually grab those. I put them up on if I could type, I put them up on my Hugging Face, and for whatever reason people have been downloading the heck out of them, and I put them up like to 3 days ago, and they've already got 70 downloads on the dang transcriber and 47 on the captioner. And they're not like normal models. I mean, they're written, even if you look at the model card for it, it tells you that it's built specifically for my app. But hey, people are downloading them, so whatever. Yeah, that's fine. So it's MIT licensed or whatever, so that's all good. Let's see, did this guy ever come back with anything? See, he's got some sub agents running. So he's trying to do, again, it's 2.5 gigs worth of data it's parsing through for this guy right here. And so this is the data set builder, and I got it set up where you can, if you've got local music, you can point it to it here, or if there's like a playlist or something on YouTube, you can point it to it there, and it'll use UT-DLP to go download it and package it all up. And then you run basically the enriched data set, and it'll scan it and caption it, get the lyrics out, tell you what the BPM is, what key it's in, what the time signature is, what language it is, all the different things, create all the sidecars and all that. And then once it gets all done, you obviously review it. Like I got that one warning right there, and it's being slow because I got that model back there churning. So sometimes it won't, so like this one, we don't have a key. And so that's the warning, which is not the end of the world. And so once it's done its deal, you basically approve everything, make an adjustment, approve it, and then save it. And then hit that export to zip button, and then you come over to your training, and you can train it local on the machine with LoRa or Loca. And then you get to define, the different parameters. So like if we say train with LoRa, you can, what ranks you want, how many epochs you want, how many layers you're going to do, the projections, and then whether or not you want self-attention or cross-attention, and MLP, and then you get a few advanced options. And so it's all about memory usage is really what it boils down to. So if you've got the memory for it, you can do, the bigger level stuff locally on the Mac, and it takes a while depending upon how big your data set is. But then I also give you, let's close that. I give you the option to do this remotely with runpod.io. And so basically, you just click that, and it'll package it all up in a zip file. And then you can come down here and set, how many epochs you want to do, the seed you want to run it on and everything, and then zip it all up because that builds sidecars and stuff. But you can come here and create your, where's that at? There's a button here somewhere to create the account if you don't already have one. Oh, right there. And so that'll take you over to RunPod so you can create your account and then generate a token or API key so that you can interface with RunPods remotely. And the SSH key is so that you can get into the server whenever it spins one up. You can select your region. So I like North America, and then refresh availability and templates. And then these are all the GPUs that are available in North America right now. And so you pick which one you want. So I want this RTX Pro 6000, and it'll automatically select the correct template for you. And you specify the container disk is like the OS drive, and then the volume is where all your work happens. So if you've got a big, large data set, you can come in here and be like, give me 200 gigs or whatever, or 300 gigs or however much you think you're going to need. And then you click that launch button and it'll go spin that server up and refresh. And then you'll see it listed right here under pods. And once the server comes online fully, it'll show you the options. So you can essentially, two ways to do it. You can click the button and make it do it, or you can click a button and copy the commands and then SSH into the machine and just paste the commands, and it'll do it for you, or you do it yourself basically. But it runs all the scripts and stuff, so it's more of a manual process, but not manual enough that you got to go in there and create the environment and compile torch and all the things that have to happen in order to do any kind of training. So it's kind of automated to some degree if you do it like that, but the buttons work. So you can actually go in there and just click the button and it'll copy the zip file that you created with this, like that one right there, the test that I ran right there. It'll copy it up there. It'll copy the runner up there that kind of runs everything, extract all the files, build the environment. Did we ever get any result back from this guy? So he's still churning. And that's what I'm saying. That's the difference, right? You see how long this has taken because it's running on the Mac. And that's simply the fact of the matter. The Macs can do it, but they're by no means fast. And again, this is the 6-bit model, so that does slow it down a little bit, but not, significantly versus a 4-bit. It would still be fairly slow because, again, they're just not, Apple isn't up to spec with NVIDIA. And so, and then it'll initiate the training, or it'll build the environment. And then once the environment gets built, the next button lights up, and then you can click the start button and it'll start the building process. So it's got to build that environment, which will take a little while. And then once the environment's built, the start button or the train button lights up. And then so you click the train button, and that, talks to the runner, and the runner initiates the actual training part of it based on the specifications that you've defined and what model you're going to train against. Are we doing instruments? Are we doing vocals? Are we doing a full mix? Are we doing wide, narrow, LoRa, Loca? And those are all kind of predefined because I figured, look, if you know what details about that kind of stuff, you just sidestep yourself and run your own training. You don't necessarily need to run an automated type of a training. But for a new person who doesn't 100% understand all of this stuff, i.e. me, just to try to simplify it, and this works out pretty good. It makes it a lot easier because you don't need to know, a lot of the details, but it tells you what the recipe is right here. And so you can switch to narrow, and you see how we pull out some of the targets go out. The rank, well, it's different with Loca, but we switch to LoRa. The rank goes down, the alpha goes down. Actually, that shouldn't be 64. That should be 128. I need to adjust that. Okay, so see, I just found a bug. But it's just automated. And then once the training gets done, it basically will pull down all of the adapters that it created. And the adapters are essentially these. I did these on my Linux box, but it's going to look like this. Well, that's not a good example. That's a little bit better of an example. There'll be more to it than that, though. So, like, here, let's go. Here, let me close that. And then let's go back over. Oop, wrong button. Let's go back over here. And so, like, if we go into, like, my sidestep folder, this is where I trained all of these guys right here. And if we go into the output folder, and then we go into one of the trainings I did, let's do that TD, damn it, if I could find the right key, R. And then go into that checkpoint folder. And then so I stopped this one early because you can turn on, like if your loss levels out, you can have it just automatically stop for you. And so it stopped at epic 50. And we go in there and look. And then that's basically whatever one it was I did here, which would probably be number 1. And so it gives you the adapters. It tells you a little bit about what it was trained against, or what it was trained against, how many epics you did, how many steps you did, just kind of the details of what that LoRa adapter is about, right? I trained on the XL SFT model, a specialized fine tune. We output into the checkpoints directory. The tensors were in that folder, just all the little details about the training session that we ran. And that's essentially what you get back from my app to a degree. Right there. It'll pull all that stuff back and then automatically import it for you. And so when you go to your generate tab here, you've got your adapters. And then these are all the adapters I've done. And you can also go to the settings and look at the adapters. We're already here, and it tells you a little bit about, that's the model it was trained against. This is how we got it. I imported it rather than trained it locally. Like this one, I trained on my Mac, and I trained on my Mac, and I trained on my Mac. All these were on my Mac. Those two were imported as well, but it tells you, when you do it on the Mac, it'll tell you the loss level on it, what we got on it. And the locas are always higher. I know, like if you look at that 7.5, and that's 6.5, and that's 6.9, and that's 5.4. And then you look at the 1.0s, and you're like, well, that's not going to work, but it does, because it's a different format. It's a totally different style of an adapter. And, but it'll automatically import them for you. You can merge some of them together. So like on my bottom 2 right here, I've got a voice and instruments. And so if I wanted to, I could merge them 2 together and make it into one. If for some reason you wanted to do that, and you can import them here. So if there's a Hugging Face one, you can plug it in right here and it'll list it, and you can import it from there, or you can import, oh yeah, well there it is right there, the repository from Hugging Face, or you can choose a folder, and like I could point to like that right there, and if I click import, it would import it, which it's already imported, so I won't do it again. But and then you just hit OK, and then come back to your adapters, and you'd see it right there. So like that, it's named after the folder, Linux Local Test 1, which is right there. And so that is this model. And it tells you, kind of what some of the specifications are. Like the LoRa rank 256, that's like stuffed. I mean, that's a powerful adapter. And so I ended up having to put in this slider of how much strength that it gets, because some of them were like low, so I needed to go up. But with that 256 one, I got to go way down. Anything past about 0.3 or 0.4, it overdrives it. It's all just static. And so it doesn't work out good. You got the full history of everything that's done, all the sidecars and everything's with it, all the prompts, all the lyrics, everything comes along with it, which is really cool. See, this has been going for 19 minutes now. And so that's the disadvantage to trying to do vibe coding on a Mac, because it's definitely slow. Vibe coding, you got to be quick. You know, I mean, I'd already be on to about 20 other things at this point, but I added this where I can basically select one. So like, let's just do, I think that's going to be a long one. We'll do like 120. That was only 140. Let's grab that one. And so now I can reopen it in the generate tab. So if I wanted to change the lyrics or change the prompting a little bit or whatever that case might be, I can. I can click the edit button now and it'll pull it into the editor. And I went through and kind of added like a mastering mix to it. And again, this is everything in the whole app is controllable via MCP. So I could have Grok, I could have Chat GPT or GPT 5.6 or, you know, whatever other model I want can connect to it via MCP and drive it. And those are all of the tools that are exposed via MCP to an external model. And as well, for parts of it, I ended up adding a 8 billion parameter in for lyric generation, a little bit better quality, as well as my local subscription models, which for some reason Grok is saying it needs to log in, which it doesn't. I've been having issues with that and haven't quite nailed down exactly what it is. As well, I can use API keys. So you can go in here and drop your API key in. The software doesn't store any of the keys. It uses the keychain and, you know, security best practices and all of that good stuff. But you can pick which one you want to actually generate your lyrics, or not your, the lyrics for you. And then for your prompt enhancement, it'll use one of these two. And so back to this, I ended up adding in like a mastering tool in my editor so that I can kind of fine tune the track that I just made to make it a little bit better quality, you know, as far as like what it's going to be doing, whether we're going to be streaming it, whether we're going to be like playing at a club, or we just want to do like a gentle smooth over the whole thing, or whatever that case is. It like makes the master track essentially is what it is. And as well as some, I already had normalize and reverb, but we added loudness and limits, like gating on the limits and stuff, soft gates, and compressing it down, and high pass filters, and, you know, all of the stuff that a normal digital audio workstation would have, but not full. It's not like it's trying to be like Logic for Apple, you know, but I did want it to be good enough to be able to make a good quality song, so that whenever I import these into my Apple Music, which I've made basically like an album at this point, I've got my own album covers and everything in my playlist and stuff, so that I can listen to my own music in my vehicle when I'm driving down the road. And so this is the output I've been getting. I don't burn loud, I burn true. There's a fire that doesn't smoke, doesn't beg, doesn't choke. And so these are all, again, and it answers only from my software. You've earned the right to feel the heat without needing to compete. I keep it cold so it won't waste. Using the adapters and stuff. So again, you can basically hot flames die in open air. Tailor your music, you know. So if you like a certain style of music, you can kind of customize it, you know. So you can basically take the idea or the, you know, I don't know, as an example, you like Iron Maiden, the way they play or whatever, you can go train an adapter on Iron Maiden and then output songs that use some of that information to create new songs. And so that's that. And then so like if we go and we load up my testing preset here, and so you can see like these are the lyrics that I've got, these are the prompt that I've got, and then if I click the enhance button right there, it'll basically check what I've got out and then tune it if it needs it. And this is the Llama 8 billion that's doing this right now. And of course, it's going to be a little bit slower because I've got open code over here churning away still, I'm sure. Yeah. And so you can see it adjusted it just a little bit, which I got the prompt came from Grok, so it's already pretty good for what it is. And then, of course, I would select my adapter and then set my strength based on what the adapter was trained against and how it was trained. All that matters. But you can iterate, you know, so if I just leave it at the default as 1 and then I generate and then I listen to the song and it's like all static or, you know, it doesn't sound real good, I can tune it up or down depending upon what I'm hearing. And the same thing with your guidances and stuff. For my experience so far has been anything other than constant on the XL model doesn't sound quite as good, which I haven't tested it lately. Actually, I need to take another look at it after all of the changes I've made. But constant, if you're using the turbo model or one of the smaller models, like I can come over here and switch to a different model. So right now, I don't even have them downloaded. But if I switch to that turbo model right there, it would deactivate the one that's currently active and then activate this one, which you can see is only 4.8 gigs versus 20 gigs. And so the quality is not as good. They still sound good. The turbos are kind of weak, but the full and the SFT base models are actually pretty good. But I always use the XLs because I've got the memory for it, and hell, why not? But I could switch the model and then it'll automatically adjust the steps, you know, just depending upon which model you're running. XLs take 50 by default, and any of the normal models take 8, which you can adjust that. It's set to auto, but if you wanted, like for the stuff I do for my vehicle, I'll set it to 85 steps, so to get the extra good quality. And I like to run one of these, but I got that other model loaded, so I can't. And you can see, I mean, again, this thing's been running for half an hour now, and we still haven't got any output yet. Control X. Control X. Down. And so there's the sub-agents that are doing their thing. So again, I told it to do a deep review, so I mean, it's expected that it's going to take a while. If you're just trying to do basic coding and you've got some context built up, so it knows kind of what's going on already, it wouldn't take this long. But again, that prompt that I gave it is the reason why it's taken so long, because I told it to do a deep review. And so it's going to go through and look at literally everything, and which is why it's taken so long. But had we been working on something, it wouldn't be near as long, you know? So, I mean, again, it's all perspective and how you're prompting and whatnot. And so how do I, what do I do? Up. And so he's waiting on the agents to come back. And again, this is a fine tune so that it's decensored, and they run this hectic program on it to do whatever that does. I looked it up a while back. I don't remember it right offhand, but it's a pretty decent model as far as if you want it to do things that your normal models will refuse to do. This one ain't scared. Say it like that. Shoot. But you can see now, like if we go back and look at our dashboard, which I've already got up, I mean, we've run through 1.5 million pre-fill tokens. We've cached 1.1 million of them, and we've hit it, 74% efficiency on it. We've been averaging about 44 tokens per second. And again, this is on that 3.5B MOE, whereas when I did it off of my NVIDIA GPU, that 4500 Pro, I mean, we were getting close to 150 is what I consistently get off of that. And so, I mean, that's 2 times higher off of that GPU with less memory. Keep that in mind, and a full context. And so you can see I've got 16 gigs worth of cache right now out of the 55 I've allocated across 170 files. And so you can kind of get an idea. And the cool thing about the oMLX is that they give you a lot of different tools that you can use. And so, like, for this model, I've got at least oh no, that's right. If we go back to the manager and then we go to the settings for the model, so they give you the different MTP, the D-Flash, which is what I run, which uses that D-Flash model. And again, basically what that does, it's a different version of speculative decoding, which is essentially the small model will recommend tokens and send them to the main model, and if the model chooses it, it saves the main model from having to go look at what that token would be. So it speeds things up. And so that's some of the benefits to using oMLX, because it does allow you to tune things very low level and get the maximum amount of speed out that you can with what you're working with. But as well, they have the benchmarking tools built right in. So if you get a new model and you want to see, how it handles prompt processing at 2 or 4 or 8 batches, you can run a benchmark against it, and it'll tell you, how quick the model is and how fast it is decoding and prompt processing. You can select a different model and go to town on it. Or if you want to see how smart your model is, they've got all of the different AI testing tools kind of built right into the app, and so you can go pick which ones you want and then run it, and you got to select a model. So if we just pick a model and then run it, and then it'll run these evaluations against how intelligent, quote unquote, the model is, and all these mean things. You can kind of look it up, like hard knowledge, that one's something in Chinese, common sense reasoning, like common sense. The one that always comes to mind is I'm going to wash my car. The car wash is 100 meters away. Would it be more efficient for me to walk over there or to drive? Right. And a lot of the models will be like, oh, you should just walk. Never mind that I'm trying to wash the car. So obviously I need to bring the car to wash the car. And if I walk, I'm not bringing the car. So common sense. And then science reasoning, conference resolution, whatever the heck that's going to mean, math, quantitative reasoning. And so the coding tests, how safe they are. So like this one would be a good one to run against this particular model because it's uncensored. So it should fail. That one is essentially what you want. So you want to do anything rather than be like, no, I'm not going to tell you how to do that because you could do bad things, like Fable. And so that's another benefit to running oMLX, because it's got a lot of feature rich, we'll call it. And as well, it's got its own chat, right? It doesn't have hands, so it can't like access your file system from here or anything like that, but you can get in here and have conversations with it. As you can see, I've been running, like a bunch of haze and stuff, just trying to load the, warm it up is what I like to call it, warm the model up. And so you can do that, right? Built-in chat. And again, it tells you your prefill and your tokens per second and time to first token and all the little juicy details that a lot of people want to know about a new model that's just come out. And so that's oMLX. And again, that thing is still running, man. And then what was that? Control X down. And so it's still churning. He's got his sub agents in there doing its thing, compaction. So it's already compacted because, again, it's filled the token or the context budget up a couple times over at this point, I'm sure. That's good as using RG. Sweet. Which is rip grep. It's a lot faster than regular grep. And so, but you can see it's been ripping through, I guess this is what it's looking for. And then this is the output of all of that. And so he's still chugging. And what do I have other? Yeah, okay, so that's a different agent right there. That's a back to the first one, it looks like. And so we got one agent running. And that's the parent guy sitting there waiting to get a reply back from the other agent. And so this has been like, what, a half an hour, 20, 30 minutes. And we still haven't got, the answer to that question yet. And that's the difference. Whereas if I could go fire up my Linux box agent and we'd already had answered this question about 9 times over at this point. And hell, as a matter of fact, let's do it. I'm going to grab that exact right here. And then we're going to go to another terminal. We're going to go back over to my machine over here. We're going to go over here. We're going to open up our LM Studio once again. Let it get loaded up. Okay, so it's loaded. And then we're going to come back to my terminal. And we're going to load up Pi this time. And we're going to switch to the dense model. And see, that other one we're running is this model right here. Same model. Except I think it's from Frogger or whatever. And this is 4-bit. The other one's 6-bit. So that's a little bit of a difference. So we'll go ahead and run we want that guy right there. We're going to run the dense model. Right? And then we're going to paste in the same prompt, same code base, same everything, different accelerator. And again, keep in mind, that other one is still running. $180 plus source files. It's going to churn through. And I guarantee you, we'll get an answer from this one before we get the answer to this one. And again, that's Mac versus NVIDIA. And that's basically equates to oMLX versus CUDA. And then I can fire up, like over here, I have, like if we go, let me go to another terminal right here. So if we go into my AI directory, and I've got a couple of scripts, start v LLM. This guy right here basically starts my VLLM server up with that model right there, NVFP4, which is the native NVIDIA format that's designed for the Blackwell chipset, which is what I've got. And it's still slower than LM Studio. And again, I haven't really tweaked it. I got to do some tuning on it because I'm pretty sure I can get some better performance out of it. But right now, LM Studio on my Linux box is smoking. And again, so on my dense model, the 27B, all 27 billion parameters loaded into memory, we're still churning out 52 tokens a second, averaging 64.9. And it's done. Here it is right here. And seeing what I like to do to show you the difference is we can bring up another terminal right here. And in here we'll go, oh, that was what I was looking for right there. So we'll bring up Grok, and then we can basically take some of what he said and paste it into Grok and let Grok kind of pick it apart. And again, there's at no level will a local model, at least not today, outperform a frontier. And so like if I copy this and then we come back over to Grok, which was right here, and be like, hey Grok, Quinn 3.6 27B says we have some issues, and you tell me if it is correct or not. No code changes, please. And then paste in, and then let Grok, he'll look at what Quinn said, and then give me a no, kind of right, but not really. It's generally what it turns out to be. And again, you see, we still haven't got an answer from here. So that's the difference. And that's why, as of today, it pays to run NVIDIA. I mean, there's just no other way around it. So Quinn is correct on unbound growth, wrong to frame it as a major memory defect without measuring entry counts and separating metadata RAM from audio disk. And so I'm sure it gave a good explanation as to, okay, so this is what he got right. And then that's what he's overselling it, right? So Quinn is being like, oh my God. And Grok is like, no, not really, because here's its claim: memory growth over time as a serious issue. Metadata is small. Quinn's own estimate is 1 to 5 gigs at 1,000 entries. That's noise next to the models. So again, that's why it always pays to have a reviewer, right? Because you can't trust the local models with certainty, and so that's why it's always good if you're writing code with the local model. That's fine, but you want to have a frontier model come back through and review all of that code. And so that allows you to keep the lower level subscriptions, where I can have a pro subscription at $20 a month, and I don't code with it. I have it review my local model's code, no problems, and point out the flaws, and then have it put it in a prompt that I can send back to the local model and be like, hey, here's what you got wrong, fix it. Rather than having the frontier model actually go in there and fix it. And if you use Pi, there's ways to set Pi up where it'll drive. So like in one Pi session, I've got Grok or ChatGPT or whatever, Opus 5 or whatever, as like the CEO or the technical leader, and then he's directing all the other local models to actually do things. And then a mid-range, like a GPT Terra on a medium or high effort to be like the reviewer. So Opus comes up with the plan, passes it down, the doers do it. When they're done, they hand it back to the mid-range model who's going to look at everything, the reviewer, and be like, you did this wrong, this is good, that's good, let me hand that up to Opus, but go back and fix this and that. The local models will go fix it and then hand it back to the reviewer. He'll check it again. Okay, everything looks good. Now let me hand it back up to Opus. And so you can build like a workflow, you know. And there's a tool out there called CMux that's really good for that. I get on the right keys right here, so you can get this for your Mac, where you can have a bunch of different workspaces, so you can be working on multiple things at once, and then multiple panels within the workspace, and then with Pi running in the workspace, and Pi can talk to the other workspaces, and so you can kind of coordinate. There's a guy, I don't remember his YouTube channel, but I follow him on GitHub. And so if we go to my profile, and I'm following 11 people, this dude right here, Pi.dev Dan, this guy right here is like the balls, man. As far as when you start talking about professional level stuff, this guy is on point. I don't know who he works for or what he does, but I'm sure he ain't making enough money, because he is like the grand master at this stuff. And like this fusion harness, I installed this the other day, where you can go watch his video. Oh wait, there it was, right here. It's Pi.dev Dan. That's his YouTube channel.
GPT 5.6 Soul,
but
or
he
Claude.
breaks it down in a, you know, about the proper ways that we should be leveraging all of these AIs and stuff, moving at the speed of light, because we're slow. Just like Elon said a long time ago, the slowest part is your fingers. And with AI, that's not the case. And so if you know how to do it right, you have all them doing it, and they move a lot faster than we do. They can think faster, they can type faster, they can read faster, they can do everything faster. And if you set that agentic workflow up correctly, all we're doing is reviewing. You know, I'm going to just confirm what they're telling me is accurate, and then we're moving on to the next thing. But this guy right here, if you're not following him, you're definitely making a mistake. If you want to learn how to be a professional engineer and utilizing the tools that are available to us today at the maximum level, this guy has got you covered. And he's got a bunch of good videos. Again, this one he's using Claude and GPT. And so Claude is like the manager, and GPT is like the builder. Like he got the architect and the builder. And he's using this one isn't about CMux, but he talks about the Pi agent. He talks about CMux, and he explains it all in a way that, you know, an average person can kind of understand what's going on. If you've got any kind of a concept of what you're doing out here with the AI, he's got you covered. Here's where he's talking about the teams and stuff, where you can have like a multiple groups, where I've got like builders, I've got the architect, I've got the reviewer, I've got the, you know, the documenter and stuff, and they all work in like a flow. It's like a flow chart of how they all kind of coordinate multi-agents. There's even with Pi, you can have remote agents and stuff. So like if I've got a VPS set up out there, that's my production side of the equation, and then I've got another section that's a development side of my section on two separate networks. You can set it up where the Pi agent on the production side and the Pi agent on the dev side can actually talk to each other across the damn internet and not expose any of your critical confidential data between each other. Because like if I'm working like in a database or something, and I don't want, you know, my database information, my confidential or proprietary info, I don't want that traversing the internet like that. So you can set it up where they can communicate with each other without exposing any of that data. And I mean, it's crazy, man. He's definitely got a lot of stuff that he covers that's really applicable to what's going on today with the capabilities of what we've got. And see, that thing is still running, man. I mean, how long has it been now? Too damn long. And we still haven't got no answer back from this thing yet. So that was the Pi agent. So we don't need any of that. I'm just trying to do some demos there. That is Grok. We don't need that. And so this dude is still running. More sub-agents going. Control X down arrow. And see, he's compacting again. So he's already burned through his context, and now he's back at it again. And so, again, that's just the limitation of trying to do... Well, I guess that's not the best way to phrase it. That's just the limitation of running on Apple hardware. I mean, it's good for what it is. But if you're looking to do any... Actually, I won't even say serious work, because you can definitely do serious work on that Apple. Just it's not going to be as fast. It's really what it boils down to, you know, versus running in any kind of NVIDIA CUDA type of situation. That is where you're going to get your speed from. I mean, and again, this is a 32 gig video card, RTX Pro 4500 Blackwell. It's got 32 gigs in it. It runs at 200 watts, so it's not like a damn jet engine trying to do what it's doing. It's nice and quiet. It sips power. It's fast as hell. Again, 32 gigs. You know, there's some stuff to be desired there, and you can pick it up for $3,500. Of course, you know, 5090 will smoke it, no doubt about it. It's got way more CUDA cores, way more memory bandwidth. It's just all around, you know, faster, but it's 600 watts. It's $5,000. You know, it's big, it's loud, it's hot. Whereas the 4500 here, I think I paid $3,400 for it. $3,500, we'll call it, to the door. It's plenty fast for what I use it for, which is mainly, you know, training LoRa's and doing local AI inference. And it works like a champ. I wish I had, you know, that 96 gigs right here would be a beautiful thing, but I don't have an extra 12,000 laying around to pick that up. So this is my middle of the road. And it's been working out just fine, you know. And so I'm going to go ahead. We can close this off. Actually, we're going to let that stay up. I'm going to close. We're going to interrupt that because it'll probably be a while before we get an answer for that. But you can kind of see that's really the main issue with running the Apples. You can run larger models, sure. You know, if I had 128 gig, I could run a 70 billion parameter model easy. I could run, what is it, OST 120B or whatever. And sure, you get better output sometimes, but you're going to pay in speed versus any kind of NVIDIA. I've never really tested any of the AMDs. I upgraded my, I had or still have it technically, AMD 7900 GRE, 16 gigs on it. It's great for gaming and all that, but 16 gigs, you're just not going to run any kind of serious model with that. And so, you know, there's really no competing AMD card that you're going to get like a normal person. I mean, I know they have their server grade stuff, one or two, that has lots of memory and GDDR6, I think it is. Let's wait, close that out. Let's go over here to console. Yeah, that guy right there, MI300X. It's got 192 gigs of VRAM in it. And I'm sure that's probably a pretty decent card too, but again, there's no CUDA. And for whatever reason, just the world we live in right now, CUDA is like the dominator. And hopefully that won't always be the case, but as of today, that's the fact. You know, I mean, like this guy right here is the absolute unit. I mean, 288 gigs of VRAM on that B300. Of course, it's $7 an hour to run that thing, but you're going to get some stuff done. You know, I mean, that's a lot. And there's 8 of them. So if I wanted to, I could come in here and be like, I want 8 of them bitches lined up for $59 an hour. It's going to charge me for that. But I mean, you know, that's some serious compute right there, baby. I mean, hell, that's 2 gigs of freaking, or 2.3 gigs of VRAM right there. I mean, that's like the mother load, you know. I mean, you can run, you know, Kimmy K damn 3 or whatever, some damn 2.8 trillion billion parameter, or 2.8 trillion parameter model in that thing, and or some training, or, you know, whatever you want, because you definitely have the capability with respects to that compared to anything else that you're going to get. That's like the best of the best as it stands today. Excuse me. And so, yeah, you know, so if you're looking to do some serious work, like these are well worth it. You know, there's a 4000, that's what I've got right there. You can regionalize it, you know, so if you want just North America, some of them aren't available, but like these RTX Pro 6000s, that thing is a monster as far as like a normal person type of have any kind of hope of ever obtaining something like that. It's a monster. I rent them all the time. Actually, I haven't rented it since I got my 4500, but you know, for $2 an hour, I can get a machine that's damn, that's all that thing is. Oh, that's that NVIDIA. Never mind. Or that's the AMD. I can get a machine that's got 96 gigs of VRAM on it. It's the newest Blackwell chipset. I get 188 gigs of memory with 16 virtual cores and any size of a disk I want. And for $2 an hour, I mean, you know, hello, that's a good deal as far as if you need some high speed, high capacity, high memory capacity, high bandwidth type of GPUs for whatever you're running. That's a good deal. I mean, I could rent that thing for, you know, 4, 5, 6 hours and spend, you know, $6, $8, $10 and get my job done, which usually is like 6 hours on training and stuff for LoRa's and stuff like that. So this is really overkill for that, but the option is available. And so it's all in what you're trying to do, you know, local, small little projects and stuff. Local LLMs are fine. High level stuff, like with my audio tool right here, there was at one point me and Opus, I think it was 4.6 at the time, we spent hours, about an hour and 45 minutes trying to debug one issue, like 1.5 million tokens we ran through. I had it running just test after test because I couldn't get any music out and it couldn't figure out why. And finally, I have another audio tool I wrote, and I'm like, look, this one works, right? And this is basically a mirror of that one, except this one's all Swift MLX. The other one's in Python and PyTorch and stuff. And so he was basically just running through everything that the other one would do and what this one wouldn't do, and then comparing how the other one was built, and then translating it into Swift MLX to figure out what was off, basically. And that's what led us into all the diagnostic, where I added a button specifically for verbose diagnostic on the audio stuff, so that we could within the Xcode debug window here, like see every step, what was filling, what was, you know, were there any nans anywhere, was it, you know, what was the output of everything that was going on, just so that we could try to debug this freaking problem. And like all these logs, which I just deleted like probably, man, 500 of them earlier today. I was trying to show Grok some other issue I was having, and I pointed him to the log directory and noticed that I had pages and pages and pages of damn logs back to damn like May in here. And I was like, dude, we need to add a way to keep this kind of capped, man, because that folder's growing at a rapid rate, you know, and we need to get that under control. And so Grok put that in for me. And it basically tells you, you know, like everything that's kind of going on so that you can see, you know, where your problem might have been. But it all grew from that one instance of that issue that me and Opus were just drilling on for hours. And I even told him after it was done, I was like, man, that was like a hell of a session, bro. And he was like, yeah, that sure was, because it, you know, and blah blah blah. And I just told him, look, make sure you document all of that stuff, man. Put that in the damn MD file so that we don't what am I looking for, so that we don't lose all that hard work that we did. I'm logged out of all that. Yes. Okay. And then so close that. Well, and then, yeah, and see, so you can see we generated 30 gigs worth of damn cache, or no, 27 gigs worth of cache. We're burning up 30 gigs worth of memory right now. And again, you can unload it. That's another cool thing I like about settings, models, and then that's the one that's loaded. And then so I can just unload it, and you see my memory just dump. There it goes. And so now I'm free to move around the cabin. And then we'll go ahead and run this right here real quick. What so we want number 3. And I want to turn it down to about right here. We'll try that. And then let that generate real quick. What settings was that? Should have been, 120 seconds. Okay, good. And then so oMLX is really good for Apple. I mean, it's definitely better than Ollama. And I'd be willing to bet that LM Studio on the Apple is probably pretty damn good too, because those guys are on top of it, their game with whatever the company is that makes that software. They're good about keeping up to the latest everything's. And but it all boils down to what that back end is all about, you know. And so for here, we'll basically close that out. We don't need that. What is this? We don't need, that's the oMLX page. We don't need that. And then we'll close that out altogether. And that's it. And so we've got it generating right now. I got this analyzer thing here that kind of steps through what it's doing. From the bottom up, that's the first thing, and then it just goes up. So first thing it did was evict everything out of memory, and then started the 8-step pipeline. Get the plan, loading the models, applying the adapter, encoding the prompt and the lyrics, and then it's running it through the diffusion. The actual make the music, tells you everything that's going on, what the lyrics are, what the prompt was, what model we're running it against, the time, the seed we run, the guidance, the preset for the guidance, what precision we're doing, how many steps. Oh, I set that to 85. Damn, I didn't realize that. It'll take a little bit longer. And then whilst we wait, we're going to take this guy, put it back over here where he belongs. Got a second monitor in the vertical over here. One issue I noticed with my new 4500 is I've got like this old Asus VG248 display from about 10, 12 years ago that I've had forever. I bought it brand new and it's 1080p. It's got one display port. It's got one or maybe two HDMIs and a DVI D port on it. And so that tells you how old it is. And it works fine, 144 hertz. But for whatever reason, my new 4500 won't pick it up. It sees it. And so like if I get over here and I do a what the hell is that command? It might be V. Right there. It just won't. It sees the graphics cards there, but it won't turn it on. The signal never completes, so it doesn't get like all the resolutions that it supports. And all the AI, I've asked Grok, I've asked GPT to look at it, and they're all saying that, look, it's a brand new graphics card working on a 12-year-old monitor is what your problem is going to be. You know, because I've swapped cables from my other monitor's 1440p. It's a newer, maybe 2 years old at this point, monitor, and it works fine. I get 144 or 240 hertz out of it. Everything's good. So I've swapped cables to make sure that it wasn't a cable issue. And that's Linux. And then I dual boot into Windows as well on that 4500. And same thing happens on Windows. And so again, that second monitor just will not come on. The full, it's not getting the full display information back from the monitor. It sees that it's there, but it just won't finish the sync part so that the computer, or so that the GPU knows what resolutions basically that the monitor can handle are. And so it refuses to, it'll like when it goes into power save mode or whatever, and I like push the button to turn it on, it comes on, but then it pops up, you know, display port, no signal detected, and then it goes right back to sleep. And so, yeah, just not working. And so I ended up turning it vertical and just keep it hooked up to my Mac at this point. And I think I'm just going to leave it like that. I might buy another one. I was looking at some today to replace it, but it still works fine. I feel bad to go buy another damn $200-300 monitor just because, although I do like my dual displays, which I get it on my Mac, just not on this new graphics card. That's why mainly I just run it all into my little Windows app here to get my remote desktops in. Because again, I don't really need to be on the Linux box, simply because I do everything on my Mac anyway. And usually I just fire up like a training session. So I installed Sidestep, which is the tool I use to do all my adapter training. And it kind of looks like this. This Electron front end. This is the easy mode. Then you've got the advanced mode where you can do all of the settings, you know, and how you want your adapter to train, what your data sets are, your pre-processing, which again is going to get you your lyrics and your captions and all of that kind of crap, and then create all the tensors that it trains off of. And then they've got an additional one here, this pre-processing plus, which I'm not 100% sure what it does, but I know it uses this, it creates another set of tensors for it and creates this JSON file that the LoRa's will look at. Like right there, it only works with LoRa's and Dora adapters. And the output's good. I mean, that's what really I know. And so like all of the adapters I've made with this thing are all like solid. And so basically, yeah, I'll set up a training run and just bring the monitor up right here so I can watch the loss and the learning rates and all the things, and then just, go work on my Mac and do everything I do on my Mac, and just keep this guy kind of running in this little window right here. And I don't ever, I got a keyboard and a mouse and everything hooked up to it, but I don't ever use it because I don't need to. And so it works pretty good. But that's kind of like my tooling and how I do it. I use VS Code for looking at files. I don't do any editing out of VS Code because, again, AI does like pretty much 100% of my work for me. All I do is tell it what I want. And if I see an error, tell it what I'm seeing, copy an error message, paste it in, and it goes and fixes everything. And then I'll fire it up and test. So, like, it works really well. Because, I've got some stuff that, like, if we go look at some of my other repos, not documents, developer, Git repos. And so, like, my Unreal MCP, which is basically done, I was like just about to be ready to go put it online right here. Oh, wait, what is that? Okay. But then they came out with the damn 5.8 that has its own MCP. And so I was like, well, damn it. And that's fine. I still might just release it. I don't know yet, but it's basically ready to go. I got like a little handful of little details to finish up on it. All right, let's see what we got here. And then I'm going to get out of here. It's freaking 6 o'clock in the morning.
Whoa, there's a morning with the rain
you see.
coming down.
And you hear how it's kind of all like,
Another empty bottle, lonesome town.
oh, that actually sounds okay.
She packed up her suitcase
And so I overdrove it.
and she walked out the door.
So it should have been a 2.
Left me with these blues and I can't take no more.
You can hear it, definitely.
Dark blue on the midnight train. Dark blue.
Versus like one of the other ones I did right here on my, if I could get a free spot on my desktop.
Woke up this morning with the rain coming down.
So you should hear the difference between,
Another lonesome town.
which this was a different adapter, but same
Packed up a
preset.
suitcase, she walked out the door. Left me with these blues and I can't take no more. Dark blues riding on the midnight train.
And so that was just because I went with the 3. And again, because if you look at that model, the LoRa 3, I drove that one hard. You can see it's ranked 256. So it's like, I won't say overtrained, but it's definitely packed a lot into that adapter. And so anything over 0.2, it kind of muddies it up. And so that's the problem. That's why it sounds like that. And why did it? Oh, because I changed that a minute ago whenever I was demoing. I didn't realize I did that. But if I was to just set it, and it's amazing how much just that little change right there is going to make if I were to regenerate it, which I'm not going to do because I need to go to bed. But that little change right there is going to make like a huge difference, It's just crazy. And so, all right, that's all I've got. I just wanted to kind of give a rundown. I don't know what possessed me to jump online. I was watching that other guy and I think he was from India, and just the way he was doing his stuff, I was trying to tell him through chat, look, dude, you need to upgrade your process a little bit because you're like lagging, and so I just figured I'd jump on and make kind of a video about some of the processes that are like current standards these days, and hopefully somebody will watch the video here and get some kind of good info out of it. And if you got any kind of questions or anything, you can feel free to comment down there, I will definitely answer them. I always answer all questions when I see them, and help if I can. And so, yeah, that's it. We're going to sign out here from Temp Studios, and feel free to like, subscribe, all the typical YouTube stuff. And I hope you'll have a good night and good luck in your AI ventures.